Alright, so one thing I forgot to include in the video on writing linear equations is that you can also write linear equations that represent something that is more imprecise data points, or what you guys probably have heard of before called a scatter plot. So what we're going to do is we're going to look at a couple of examples of using the calculator to help me do that. Now you can technically do this by hand by taking the x's and the y's and graphing them, and then plotting those points on the graph, making a best fitting line using your eyes to find the one that fits the best. That's why it's called a best fitting line. And then using your skills that we learned in the writing equations video of finding the slope and the y-intercept. That's an option. But there is also the technology option. And so that's what we're going to look at real quick. I'm going to use this one on the right first. I'll move it over here so you can, since I'm going to be using it first. I'm going to find the equation for this one because this one is a little bit more precise. It's a little bit prettier numbers here. So we're going to plug in a table. So if I had you practice this earlier in the very first instruction module, the introduction module, and I'm practicing the Desmos activity. So what we want to do is we want to take this guy here. Oh, come on now. And we're going to make a table here. And we're going to plug in the numbers that come from our x's, 1, 2, 3, 4, and 5. And I'm going to substitute those numbers in for x. 1, 2, 3. Notice Desmos actually keeps going for me. 4, 5. It sees that I'm doing a little pattern there. Then I'm going to plug in my y values, 2, 3, 4, 5, 6. So I'm going to come to my calculator, and I'm going to plug in 2, 3, 4. Now notice it doesn't give me these because it doesn't want to assume that the y's actually have a pattern. That's what we're about to figure out. Now on this calculator, you'll see this little zoom button right here. It says zoom fit usually when you hover over the top of it. I don't know why it's not doing that today. Oh, and great. This thing's going to start liking me. So we zoom in and we can see the points. Notice these make a line across the graph. That's how I know it's linear. What I want to do now is I'm going to come down to the next little block, and I'm going to find the equation of that line. If the points are not very precise, it will find the best fitting equation. If they're very precise, it'll find the exact equation. But the way that you do this is you want to find y equals mx plus b, just like we did by hand. So we type in y, but we're going to have to put y1, so it knows we're talking about these y values here. And then we use this little squiggly looking sign. It's kind of half of an equal sign, squiggly. It's meaning that the calculator is going to approximate the best fitting line. So if you look up there on your keyboard, up next to the number 1 on the left, you'll see it. Then we type in mx, but we also have to put the little 1 to know it's coming from this side of our chart, plus b. And so what it does is it finds the line that fits those points for me, and it tells me m is 1 and b is 1. So that tells me my equation would be y equals 1x plus 1. So what this does is this gives me the ability to go through and to find an equation of a line even if I don't have real pretty points. Oh. Sorry guys. I don't know what's going on here. Alright. So now we're going to use this other one over here, and this one might not be as pretty with our numbers over here. We got 1, 2, 3, 4 for our x, so we're going to plug in 1, 2, 3, 4. So I'm going to delete 5 here. And then we're going to use 17, 21, 23, 26, 34. So we go over here, and we go with 17, 21, 23, and then we have 26 and 34. So 26. Oh, wow. Oh, what did I do there? Oh, goofy mistake here. There's 2 2's right here. Everybody see that? That's important to pay attention to. And Mr. Harrison made a goofy mistake here. Wow, this thing is acting up on me right now. 3 here and 4 here. Notice because wow, come on thing. Man, this thing is really not liking me right now. Alright, let's try that. Notice that when I find this one, the points are not perfectly in a line, but it can still find the M and the B for me that approximates what those points are doing. And it's not perfect, but it's pretty close. You'll get into some statistics classes probably in college and talk about these R values right here that talks about how good the points, the line actually fits the points. But that gives me my M and my B. Y equals 5.5x plus 11. So that is my M and my B for my equation of my line. So this is how, even if you don't have access to, TI calculators, or you don't have access to paper, you can use Desmos. They have a little app on your phone. You can find the approximation of a best fitting line if you're looking at outputs on your computer at work or something, and you notice that it looks like it's a linear pattern. You can figure out what it is and what it's doing and make predictions for your boss. So, and again, I'm just kind of talking about possible things that could happen, but I'm not saying you're going to do this every day of your life. That's not what I'm saying. So you have this ability to plug in a table and tell the calculator to find the y equals mx plus b. Just notice it's y1 and x1, and notice that you use this little squiggly equal sign thing. Alright, let's see if I can get this thing to stop.